So let's go ahead and practice dilutions and calculating molarity for solutions. So notice this first problem here. Calculate the molarity of a solution made by dissolving 0.145 moles sodium sulfate in water to form exactly 750 milliliters of solution. So we got to recall what the unit of molarity is. So big M has units of mole of solute per liter of solution. Well, the volume is given here. That is the volume of the solution. Here's the moles of the solute. It's already in moles. And so in order to calculate this molarity, we put in 0.145 mole of Na2SO4. And then down here, we got to convert this into liters, so 750 ml times, remember the conversion between there, 1000 ml for every 1 liter, end up being 0.750 liters. So we put that there, 0.750 liters. Get out our handy calculator. Oh, let me move this so you guys can see, so I can see. 0.145 divided by 0.750, and we end up with 0.1933333. A lot of threes. Okay, 0.193 molar solution. So right here we would do 0.193 molar of Na2SO4. Now, let's look at this next problem. How many moles of potassium permanganate are present in 125 milliliters of a 0.0850 molar solution? So this one's a little confusing because it's actually asking for how many moles of this are present in a solution. So the solution's already given, but it's telling us how many milliliters total of solution we have. So start with what's given. It's given 0.0850 molar, and it's given 125 milliliters. Well, what in the world are we going to do with that? Well, remember what molarity breaks down into. Moles of solute per liters of solution. If we have the volume of the solution, converting that into milliliters, we can actually find the number of moles of solute. So starting down here, oh, and I'm going to go ahead and convert that to liters, by the way. So that's 0.125 liters of solution times our molarity. So 0.0850, I'm going to show this, mole per 1 liter. Notice that this is this exact same thing as this. If you divide anything by 1, it's still that number. We're just showing the units here. Our liters will cancel, and then we'll end up getting the number of moles of potassium permanganate. Go back to our calculator. So 0.125 times 0.0850 end up with 0.0106 moles. So 0.0106 mole of Km, and I'm about to run out of room. Yes, I knew it. So Km, and oh, that should be a big N. Oh no, little n. 04. So that is how many moles of potassium permanganate we have there. One more problem. Okay, how many milliliters of stock solution of a 10.0 molar nitric acid would you have to use to prepare 0.350 liters of a 0.500 or 0.400 molar nitric acid? All right, so that's a lot of words right there. But let's figure out if we can, see if we can figure out what this is asking. So it's going to take, look at this, it's going to take a solution and then reduce the concentration. What is that called? That's called dilution, right? So we're going to have to use our dilution equation. So let's go ahead and start. We already know that this has got to be the concentration of the, well, the concentration of the concentrated solution, because it's lower than this one, right? And would you use to prepare 0.350 liters of this? So this is telling us how much total solution we'll have after we're dilute. So if we look at this, MC VC equals MD VD. All right. So remember, MC is molarity of the concentration, volume of the concentrated, volume of the concentrated, molarity of the diluted, volume of the diluted. We're going to again solve for the number of milliliters that we'll need of our concentrated to make our new diluted solution. So VC equals MD VD over MC, hammer. Sorry, I had to throw that one in there. Okay, all right. So here we go. Our diluted solution 0.0400 molar, and then right here we're going to do 0.350 liters divided by 10.0 molar. Notice our big M's will cancel. We'll be in units of liters. So going to our calculator, 0.4 times 350. Oh, it should be 0.3350 divided by 10 will give us 0.0140 liters. But that's not what we need, actually. It says how many milliliters of this will we need. So to convert 0.0140 liters into milliliters, we need to put 1 liter down there, 1,000 ml here. Multiply this by 1,000, so 1, 2, 3. So it should be 140. Is that right? 1, 2, 3. Yeah, 14.0 milliliters of our original stock solution. That's how much we need in order to prepare this new solution.